This is looking at Eulers' theorem, which says if we've got a graph with v vertices, e edges, and f faces, we get this equation here. Very important equation. Now I'm going to prove that this is true. So I'm going to start off first of all with a tree and just prove it's true for a tree. So in my tree, I'm just going to have 1, 2, 3, 4, 5, 6 vertices. And if there are 6 vertices, there must be 5 edges because it's a tree. So let's just make up these 5 edges like this. So as we can see, being a tree, it doesn't have any cycles, which means that I've only got one face here. Now, edges are the number of vertices equals 1, and a tree faces equals 1. So I can take my vertices, and then I'm going to take away v minus 1, and add the number of faces, 1, and it equals 2. And that's going to be true even if we start adding extra vertices. So if I add one more vertex down here, then we can add an edge from somewhere like this. We don't add any more faces. So it's going to be true all the way through for every single tree. Now, what about if we don't have a tree? So let's take this one here and let's add another vertex, but so that it now changes from a tree and we start having a cycle in there. Now, the minute we close one of those off and have a cycle, we've added one to the edge, but not to the vertex, but it also makes an extra face. So what have I got? I've got edges are now equal to the vertices. The faces are now 2. And so I have v take away edges, which are now v, plus the number of faces, which are now 2, and it equals 2. And this will continue. So if I was to put another edge on here, like here, I've now closed off this, and I've got to put the infinite face here. So every single edge that I add, I'm adding an extra face. So that now means that vertices are equal to the edges plus 1 plus 3 faces. This is v rather. And that still equals 2. V minus v plus, take away 1 plus 3 is still 2. And we can keep going. So this is the proof. The minute I make one extra edge, I always create an extra face. Because I always create that extra face, then this Eulers theorem always works. And that's the proof of why Eulers theorem works in planar graphs.